Alright, so let's take a look at this lesson number 5, which is further integration. So you need to pay attention to this a bit because it's a bit confusing, the following examples. But let me start first with the basic example, so for us to be able to take the premise of the lesson for today. So, for example, I'll take the derivative of x squared plus 2x plus 1. So as we know, the derivative of this one is actually 2x plus 2. Now, if the derivative of this one, alright, if the derivative of this one is this, what we have said before is that the opposite of that, the integral of this function 2x plus 2 with respect to x must be equal to this one here, must be equal to x squared plus 2x plus some number c. And in this question, it's actually 1. So what's the implication of this? The implication of that is, if, for example, this is our original question, and let me denote this one as a function of x. So the derivative of x, and let me denote this as my function of x. And I'll take the derivative of that, okay? And the answer, this one, let me denote as my function of x, the small f. So it says here, the integral, because these two are reversible, if the derivative of this function is the small function f, therefore the integral of the small function x with respect to x is the big F of x plus some number c. So this premise here tells us that the derivative of a function, alright, that the derivative of a function is the reverse of the integral of the derived function of this f of x. Okay, so it shows us that really the derivative and the integral are opposite with each other. Now, let's use this one for this question. All right. I think this is a bit difficult to understand right away if you're gonna go through this example. Before I go to this example, I'm gonna discuss that. But then I want to go first to this question here, example number 12. All right. Let's just try to take a look at this. Let me cover this. Okay, let me cover that one. So just open your book. So it says, given that y is equal to x squared, the square root of 3x minus 2, find the dy dx, hence find the integral of this. Okay, again, don't panic. Okay, never panic about this final question, because as long as you follow the process here, then you can find this one easily. So again, it says here, given this, you just need to find this, and hence, meaning whatever your answer here, use that to find this answer here. Okay? So how are we going to do that? What's the thinking process here? X squared times this expression. So meaning we're going to use product rule. So if you're going to use the product rule, so that will give you, where am I going to write? The space is not enough. I think it's better for me to copy this for a while. One moment. Let me pause the video so I can copy first. Alright, so let's continue with this question. Given that the y equals x squared, blah blah blah, find dy dx, hence find the integral of this expression. Again, please don't get shocked right away of the question. Just follow the instruction carefully. It says find the dy dx. Since this 2 is a product of two different functions, therefore what we need is our product formula. So let me just write my product formula again. Sorry. You have the uv, which is equal to u prime v plus uv prime. So let's take the derivative of that. So u prime, the derivative of x squared, or I'll just do it one by one, so some of you will not get confused. This symbol means prime, okay? X squared prime, then I will just rewrite this to 3x minus 2 to the half, because that's the square root is equal to raised to the half. Then it says there plus, and then I'll copy my u, which is x squared. Then I'll take the derivative of my v. So my v is this one, raised to the half, and then I'll take the derivative. I'll put this symbol that it means I need to find the derivative of this part. So the derivative of x squared is 2x, all right, times 3x minus 2 to the half, plus copy my x squared, then times the derivative of this. So the derivative of that is 1 half times 3x minus 2 to the negative 1 half times, again, the chain rule times the derivative of 3x minus 2, which is 3. All right, then that's it. So we just need to rewrite that neatly. So 2x times 3x minus 2 to the half, plus this is 1 half times 3. So that's 3 over 2x squared, then 3x minus 2 to the negative half. So this is your dy dx. So the derivative of this is this one here, all right? Then it shows there, hence, find this integral from here, right? So we're trying to find this integral here. But first of all, let me just write this one neatly, like the derivative. I just want to write the question again, and I'll put it in this way, so you would be able to see the relationship. Okay, is equal to 2x, and this is root of 3x minus 2 plus 3 over 2, the x squared is on top, okay? Then this one is at the bottom, so that is 3x minus 2, okay? That's it. So the derivative of this function is this. Now, what do we know? We know that the opposite of differentiation is integration. How shall we get the integral of this? So basically, we need to simplify the right-hand side. So the strategy is to simplify the right-hand side, and obtain the expression, this one, this encircle, right? So we want to obtain that expression, obtain this expression after you simplify this right-hand side. So let's do that. This video seems to be long now, but okay, let's just go on. So here this is over 1. So we can cross multiply. So here the bottom is 2, the square root of 3x minus 2. And when you look at it, we need this expression actually 2 square root of 3x minus 2. In our original question, it's already there. Okay? So this times that, we cross multiply. So 2 times 2 is 4x. Then 3x minus 2 times 3x minus 2 is actually 3x minus 2. So 3x minus 2 to the half times 3x minus 2 to the half is 3x minus 2 to half plus half, which is raised to 1. And then 1 times this, 1 times that. We need to multiply that one there. Okay? So this 1 times this, which we got the here. And then look at, I will rewrite this. I will rewrite this one. Please take a look of how do I write my solution. I rewrite the derivative, I rewrite the question and its answers. After I simplify, I rewrite again the original question. Okay, I want you to do it that way so you don't get confused. Let's simplify this. So this is going to be 12x squared minus 8x plus 3x squared all over 2 square root of 3x minus 2. Okay, now, and that's equal to the derivative of this one, x squared is square root of 3x minus 2. So we're almost there. Alright, so we're almost there actually. So as you can see, 12x squared minus 8x plus 3x squared. When we add this two, it will give us 15x squared, which is actually this question. The negative 8x is that question there. So basically, this expression is equal to this expression here. So let me just show that one to you clearly. Again, this expression now is 15x squared minus 8x 2 square root of 3x minus 2. So that is the derivative. Look at it that I always copy this one because I need it. So my thinking process will be systematic. So this part here is actually this portion. So therefore, when I look at the original question, the question 15x squared minus 8x, this one can be written like this. Look at that. Very wonderful. Okay, dx and then plus integral of 7 over 2 square root of 3x minus 2 dx. Okay, so again, this portion is that portion. Plus 7 over this is this portion. So when you add this part, that's actually that part. Okay, but this portion we got already. That is this portion here. Okay, so we can find this answer right away. Can you see? So the derivative of this, which is equal to that, if you want to get that expression, we can get this expression by taking the derivative of this right-hand side and this side with respect to x, with respect to x. Okay, so as you can see, this portion is exactly the same as that. But what is the integral of this? The integral of this is this one. But the integral of the derivative of this function, as what I've told you, the integral and the derivative cancels each other's out. So this portion here becomes x squared square root of 3x minus 2. Okay? This derivative has been cancelled out. So therefore, the integral of this portion is equal to that portion. Now I can take the integral of this. How shall we take the integral of this? Plus the 7 over 2, I can bring it outside. Integral of 1 over square root of 3x minus 2 dx. But what is this equal to? That's equal to plus 7 over 2 integral of 3x minus 2 raised to 1 half dx. So how can we get the integral of that? So 7 over 2, our a is 3, so times 1 over 3, alright, times 3x minus 2 to the 3 over 2 divided by 3 over 2. Okay, so let's simplify this one. So this 3 over 2, this 3 over 2 here will be times 2 over 3 like that. So therefore I can cancel the 2. Okay, so my answer now is 7 over 9. So plus 7 over 9, 3x minus 2 raised to 3 over 2. Alright, so my final answer now is x squared is square root of 3x minus 2 plus this. So this is the integral of the question, 15x squared minus 8x plus 7 all over 2 square root of 3x minus 2 with respect to x. Alright, so this is now our final answer, and I just need to add there plus c. Again, the thinking process is that you need to find the derivative of the left-hand side. Alright, find the derivative of the left-hand side, and then after taking the derivative, you need to figure out, okay, you need to figure out how could you get this expression from the derivative. Okay, so before I proceed to the next example, let me just write it down. So step number 1, you find the derivative. Okay, after finding the derivative, find ways or figure out how to obtain, okay, how to obtain the given question from the derivative, because that two are always related with each other. Okay, this one and the derivative there and the questions are always related with each other. And then if you would be able to figure out that expression, all right, then you can now equate again, or I would say you equate the question, all right, using this, right, the derivative of the original question equals to its derivative. Then you will find the last one is to integrate. I will use this method in my next example. For the meantime, I will just end this video here because it's already 18 minutes. Thank you very much.